Hi there, Andrew Jackson, AJ Design Studio. I've got another video continuing with my some of my guitar forms. So I've had some requests recently from people who have been struggling to model a volute on the back of a headstock. So as you can see here, this is my result from today. This is a continuation of my earlier model of a Les Paul Junior headstock and neck, which is this one here. So that was uploaded in 2023, models online if you want to look at it. So I decided instead of starting fresh and modeling some sort of, super strat headstock or something like that, I'll just continue with this neck with the heel modeled and everything, and just redefine this area. So I'm pretty sure this patch layout will work if you wanted to have an asymmetric headstock or something like that. So yeah, anyway, what I normally do is I've modeled this took a while, so I didn't record it live. I'll just roll through the relevant features and just explain some of the modeling strategies. But let's just spin it around first and have a look at the result. So I've got an overbuilt surface in there, plus another little patch on the end, and then that's been mirrored around. But the result's fairly good. Quite happy with it, and it's tweakable as well. And the fillets that went on afterwards, they're just straight fillets, curvature continuous fillets, but just looking at the main zebra stripes up through. Okay, I'm going to roll back now and just explain how I made this. Okay, very quickly, I have construction at the top. So this is the same as the other headstock model. So I have an elevation control with some core dimensions there. There's the fretboard dimensions, and then the next section at the nut, and then I've got the next section at the heel, and I've got the main loft there, so the back of the neck. Headstock front, it's just a plane through that control sketch, and then my headstock control sketch there for the profile on the outside of the headstock. And I've got a boss extrude for the headstock, and then end of the fretboard, just like a little nublet there, which is merged into the solid. And then the first thing I do when I get into the headstock modeling is I just delete this side face here to turn that solid into a surface model. So with the volute, I've started by defining the side elevation sketch, which controls, I guess the sketch, I've assumed that the volute, this sort of ramp up, starts at the corner of the headstock here. So that's fixed. And then I've got 2 degree 3 splines which are curvature continuous to the center line of the neck and also for the headstock. And because those are linear, those are lines, I've just made the first 2 control polygon segments of each spline collinear to those lines there, so I don't need to use the curvature continuous constraint. And then I've got dimensional control over the height of the volute, like the length of this blend. Like if you want to offset the volute, make a sort of slower run into it, and also the volute's position in relation to the nut. So the nut's, my origin's at the nut there, so you can shift that whole lot around. Okay, and the other thing is you can control the spline, how tight you want the curvature running into the volute. Okay, next after that is I've got the volute plane control. So basically in 3D space, the back edge of the volute. So that's just simply a sketch there with, again, dimensions that you can change, these angles, and the length of these, the spline polygon, control polygon segments. Okay, then I've extruded that section of the volute because this is the actual surface that's going to be running off the back of the headstock, and then that's trimmed back with the volute plane control. Okay, so this curve here is explicitly modeled. It's not an intersection of overbuilt surfaces, so I'm modeling exactly up to that edge That is the volute, if that makes sense. Okay. Next, I've trimmed back the neck here. And again, that distance of trim is in the volute side elevation control, as you can see. So a good dimension at the top there as well for that trim. Okay. Now, I've got a 3D sketch which controls like this main surface. This is the outside of the blend. I'm going to make one big surface in here. I'll roll forward and show you the surface first. Okay, so the headstock blend. So I've got this big surface here, which is tangent to the back of the neck. So we turn our zebras on. Okay, so it's tangent to the surface, and the other boundaries are free, apart from the center line, which is normal to the center line. Okay, but the main thing is I've got this exterior boundary, which is a 3D sketch, and because of the nature of that 3D sketch, I've got some controls set up to control the free end of it. So I've got these two sketches which make a reference intersection curve, as you can see there, and then the actual blend, outer blend, which is this 3D sketch here, references the intersection of these two surfaces. So that means that that end of the 3D sketch, I can change the angle in this plane. I can also change the angle in this plane, and the 3D sketch, I can control the spacing of the control polygon segments, because the front edge of this volute, where it intersects with the top of the front of the headstock, is actually resultant. So I need to have kind of tweakability, to change dimensions, to change, the fullness of that surface. Okay. I'll upload the model like usual so you can pick apart and see what I'm talking about. Okay, so after that headstock blend, that main surface, I need to make a surface to go in here. So what I've decided to do was to trim back some of this primary surface. So I've got a 3D sketch here, which is 22 mils off the center line. And then I've got a plane that's normal to this the volute edge, and it runs through that point. And then there's some extensions and trims, but basically I trim this surface back, making sure that this point is back above the top of the headstock. Okay, and then on the top of the headstock here, I've created a sketch for my second blend, which is this headstock upper blend control. So there's an intersection curve there, so this is a reference for us to get our curvature continuity on this end. So it's curvature continuous to the intersection curve of that surface, and this end is free, so I've got an angle here. Again, this is for tweaking this surface depending on what sort of fullness or curvature you want around the back of the volute here. And then that is created as a loft, four-sided loft. I found I was getting better results with a loft than with a boundary surface. Okay, that's knitted together. Got a copy of this for making the nut further down. Then I've just got a few trimming operations here. As you can see, that's a resultant. So this is the resultant edge I was talking about. This one here is defined, but it is also reliant on where the surface goes sits in 3D space. Okay, so when you look in, I'll sort of tweak some of the dimensions in here, because when you look in here on the neck, you want to kind of have this full, but you don't want to have the volute jumping out. Okay, and then that's knitted together. Fretboard top surface. I'm not going to go into this in too much detail. I've covered this in my other video. So it's just some construction there to make the fretboard with a constant radius, even though it's getting wider. And then onto the heel construction. So yeah, that's all smooth and nice in there as well. Okay, and then I've solidified everything by capping off the center line and end face. And next I've added some splits and fillets, just chop this into parts. So I created the nut and added some main fillets. So the Volute fillet here is a variable fillet that runs around. I didn't bother running a pipe along here to change it, to trim it out. Seemed to work quite well with just a fillet. And then some more splits to split out the front of the headstock, and to trim out the to split out the fretboard. Okay, and then some mirror and fillets. So as I said at the beginning, I think there's enough here. Like, you'll be able to follow a similar patch layout if you're working on asymmetric headstock, or a headstock that runs like planar or parallel to the fretboard, like a Stratocaster or Super Strat. So yeah, basically building this one big surface first, trimming back a little bit of it so you can add a second four-sided patch in. So that means we're not trying to make 5-side surfaces. We've avoided using the fill surface, so we've done this just with these sort of standard surfacing tools. Should be fairly robust. So I'm going to wrap this up there. Model will be in the description for download if you want to take this apart and have a look how I built it. All good. Thanks for watching. Andrew Jackson, AJ Design Studio. Bye.